Ever pondered about the role chemistry plays in our everyday lives? It's more than just a subject you studied in school. It's the magic that turns flour into bread. It's the energy that powers your car. It's the essence of life itself. Today, we're going to dive into the fascinating world of chemistry with some easy do-it-yourself experiments that will blow your mind and maybe even spark a lifelong love for this essential science. But before we get started, let's talk safety. Chemistry is fun, but it can also be dangerous if not handled properly. Always wear protective gear like gloves and safety glasses. Make sure to perform experiments in a well-ventilated area and never mix chemicals unless you are certain of the outcome. And remember, never eat or drink anything used in your experiments. Remember, safety first, and now, on to our first experiment. Scene script. Ever wanted to pass secret messages like a spy? Chemistry can help. Welcome to the intriguing world of invisible ink, a staple of the covert world of spies and secret agents. But guess what? You don't need to be a spy to make it. You can create your own invisible ink right at home with something as simple as lemon juice. Yes, you heard it right. Lemon juice. Here's how. You'll need a lemon, some water, a bowl, a cotton swab, and a piece of paper. Squeeze the juice out of the lemon into a bowl, add a few drops of water, and stir. Your invisible ink is ready. Dip the cotton swab into the mixture and write a secret message on the paper. Let it dry completely and voila. Your secret message has vanished as if by magic, but it's not magic, it's chemistry. This fascinating phenomenon is due to a process called oxidation. Lemon juice, being acidic, weakens the paper. When you apply heat to the paper, the weakened parts of the paper burn or oxidize faster than the rest, revealing your secret message. The juice of the lemon, in reacting with the heat, gets oxidized, and this reaction makes the invisible ink visible. But remember, the key here is to apply heat gently. We don't want to set the paper on fire. A simple way to do this is to hold the paper near a light bulb or a heat source. As the paper heats up, your hidden message will begin to appear, as if being written by an invisible hand. This process is not just fun, it's a great way to understand the principles of oxidation and chemical reactions. And let's not forget, it's a fantastic way to impress your friends with your newfound spy skills. And there you have it, your very own invisible ink, a simple yet fascinating demonstration of oxidation. Who doesn't love a good lava lamp? But did you know you can make one at home using simple chemistry? Let's dive into the process, shall we? First off, you'll need a transparent container. This can be a glass jar, a plastic bottle, or whatever you have handy. Now fill up about 3/4 of your container with a clear oil. Any oil will do, but for the best visuals, try to use a light-colored one. Next, pour water into the container until it's nearly full, leaving some space at the top. Watch how the water sinks to the bottom while the oil floats on top. That's because water is denser than oil. Remember, oil and water don't mix. Now let's add some color. Squeeze in a few drops of your favorite food coloring. Notice how it passes through the oil and mixes with the water. Fascinating, isn't it? Then comes the magic. Break an effervescent tablet into a few pieces and drop them into your container. Effervescent tablets contain substances that react to form gas when in contact with water. As the tablet dissolves in the water, it creates gas bubbles. These bubbles rise through the oil, taking some colored water along for the ride, creating blobs that look like mesmerizing lava. As the gas bubble reaches the surface, it pops and the colored water falls back down. This is because it's denser than oil. The cycle continues until the tablet is completely dissolved. What you're witnessing here is a simple yet captivating demonstration of immiscibility. That's a fancy term for the principle that explains why certain liquids, like oil and water, don't mix. It's also a great example of density in action, as the denser water sinks while the less dense oil floats. You can keep the fun going by adding more effervescent tablets whenever you want to activate your homemade lava lamp. Just remember to always handle the tablets and oil with care and clean up properly afterwards. And voila, your homemade lava lamp, a fun example of how oil and water do not mix. Slime, a favorite of kids and adults alike, but do you know what makes it so stretchy and gooey? Let's find out. Slime is more than just a fun toy. It's a fascinating example of a polymer. Polymers are long chains of molecules that give materials like slime their stretchy, flexible properties. Today, we're going to create our own slime and witness this polymerization reaction firsthand. Let's get started. You'll need some basic ingredients: white craft glue, borax, and water. The glue contains a polymer called polyvinyl acetate, which is a liquid at room temperature. When we add borax, a chemical reaction occurs that transforms these liquid polymers into a more solid state. This is what gives our slime its unique texture. First, pour about half a cup of glue into a mixing bowl. Next, add half a cup of water to the glue and stir until they're fully combined. This dilutes the glue, making it easier for the borax to interact with the polyvinyl acetate. Now, in a separate container, mix 1 teaspoon of borax with 1 cup of water. Stir until the borax is completely dissolved. This solution is going to kickstart the polymerization process. Slowly add the borax solution to the glue mixture, stirring continuously. As you stir, you'll notice the mixture starting to thicken and clump together. This is the polymerization reaction in action. The borax links the polyvinyl acetate molecules together, creating a large, flexible polymer network. This network traps water, which gives the slime its squishy, stretchy consistency. Keep stirring until the slime pulls away from the sides of the bowl and forms a ball. At this point, you can use your hands to knead the slime until it reaches your desired consistency. Remember, slime can be a bit messy, so make sure to clean up after your experiment. And while slime is safe to touch, it's not safe to eat, so keep it away from little ones who might be tempted to taste it. And there you have it, your homemade slime, a tactile and fun demonstration of polymer science. All these experiments are not just fun, they also mirror larger chemical processes that happen in the world around us. In our thrilling journey today, we've explored 3 fascinating chemistry experiments that you can easily recreate at home. But these aren't just simple parlor tricks, oh no, they serve as brilliant microcosms of the complex chemical reactions that govern our everyday lives. Our first stop was the intriguing world of invisible ink, an experiment that's as mysterious as it is educational. By using lemon juice and heat, we created our own secret messages. This process is a perfect illustration of oxidation, a reaction that involves the loss of electrons. Think rust on an old bicycle or an apple turning brown when left out in the open. That's oxidation at work. Our invisible ink experiment is a miniature version of this process, revealing how chemistry is involved in even the smallest details of our lives. Next, we dove into the colorful universe of homemade lava lamps. This experiment demonstrated the principle of immiscibility, which refers to the inability of certain liquids to mix. Just like oil and vinegar in a salad dressing, the oil and water in our lava lamp refuse to mix. Instead, they form separate layers, creating a mesmerizing display of floating blobs. This concept is seen in many real-life situations, from oil spills in the ocean to the extraction of certain medicines. Finally, we delved into the gooey realm of slime creation. By mixing glue and borax, we created a non-Newtonian fluid that behaves both as a solid and a liquid. This is an example of polymerization, where small molecules join together to form long chains. This process is fundamental to the creation of many materials we use daily, like plastics, rubber, and even DNA. So the next time you see a lava lamp or touch slime, remember there's a whole lot of chemistry involved. Keep experimenting and keep learning.